Good morning, everyone. I'd like to ask you all a favor. Would everybody please stand up? All right. Congratulations. You are all paying attention, which means you're a great audience. So thank you for being here. You can all sit down. So today, Ashish and I are going to be introducing you to an ML infrastructure called METAFLOW that promises to increase the impact of any given data scientist while scaling data science at Netflix by enabling collaboration. We take a very human-centric approach with METAFLOW, and hopefully you'll see what that means throughout the talk. And we're going to be showing METAFLOW through a case study in content machine learning that Ashish's team is working on at Netflix. So Ashish, would you mind telling us a bit about your problem?
Yeah, absolutely. Hi, everybody. So at Netflix, we have a business problem, which is we need to estimate the size of the audience of a show in the months leading up to the show's launch. And this is important for a variety of reasons, including prioritization, allocation of resources, etc. So with this business problem, we have a couple of different goals. The first goal is that we want to surface content insights consistently to everyone at the company. Netflix operates in 190 countries, and we have offices all over the world. And it's really important that everyone at the company has consistent expectations from a title in terms of its performance. So this is one reason why we want to solve this problem. The second reason is that we want to arm decision makers with accurate and timely information about how a piece of content is likely to do. And it's important to emphasize both accuracy and timeliness, because if the predictions aren't accurate, then they're not useful. And at the same time, if they're not timely, then you lose the opportunity to make decisions based on them. So that's the business problem that we're trying to solve. When I look at the data scientists on my team, they have a typical workflow, and some of this will be very relevant and resonate quite well with the audience. So this is how a project is typically structured. You start with exploration. This is when the data scientist is out in the wild, they're exploring the data, they're looking at correlations, they're looking at which features predict their target, and various signals. And this is really the time that the scientist is building intuition with the data. This is where they're sort of learning behaviors of the data and how it can be used to predict the target. And this phase can take between 2 to 4 weeks. Once the data scientist has built some intuition about how the data behaves, the next stage is prototyping. And what's at a premium at this stage is being really fast. So the data scientist would like to try out lots of different ideas, throw away many ideas that don't work, incrementally build upon the ideas that do work, experiment with a large number of sort of feature transforms or model architectures to really arrive at the most promising candidate that they think will solve the business problem. After they're and this stage typically takes about 6 to 8 weeks. After they've identified the most promising candidate, the next stage is by far the most daunting or intimidating stage for the data scientist. And I think we've already heard a couple of different talks today that mention this. But this is the task of productionalization. This is when the data scientist needs to button up their model and ship their code to production. And the set of tasks that are involved here are quite different from the first two tasks of exploration and of prototyping. So for example, here's when the data scientist really needs to build a production ETL. They need to put in some audits to make sure that the data quality that they have is good. They need to perhaps schedule model training to run on a periodic cadence, maybe weekly or daily. They need to perhaps deploy their model to a hosting service so that the predictions can be accessed in a timely manner, and a variety of other tasks. And this can take between 12 to 14 weeks and takes the most amount of time. So that's sort of the problem description for you, Julie. If you can kind of tell me how you can help me here.
Yes, I actually think METAFLOW can help you out quite a bit. And in particular, during that rapid prototyping phase, as well as the productionizing phase. I really want your data scientists to be able to even more quickly explore many ideas at once. And I want to reduce a lot of the toil for you in terms of bringing those models to productions, and hopefully we can get it down to far less than 12 weeks for you. Before I show you how to use METAFLOW, I want to walk you through the stack that's involved in bringing a machine learning model to life. And as any data scientist would know, the basic fundamental layer is going to be the data. At Netflix, we have a data warehouse that is on top of Amazon S3. And once you have that data, you're going to need to do something with it, which means you need access to some kind of compute. Most of you are familiar with Kubernetes. It gives you practically unlimited access to compute in the cloud through this virtualized, containerized environment. At Netflix, we use a similar system called Titus. Beyond that, though, you're going to want to take your job to production by training it on a scheduler. So you're going to need a production-grade scheduler, such as Airflow. At Netflix, we use one called Meson that works in a similar manner. But there's one often overlooked aspect of running production models at scale, and that is really how you version the models and how you organize your work. METAFLOW has a lot of opinionated stance on how to automate some of that away and structure your work in a way that allows your researchers to continue multiple streams of work while the production models are unaffected. Once we go up the stack, of course, you want to start using collaborative tools. I'm imagining you're probably using Jupyter notebooks, so you probably want to use that to not only explore, but also monitor your models. And then you want to get your model deployed in some way that gives timely insights, right? You're going to want to do, let's say, real-time scoring. And you probably don't want to have to worry too much about the details here. But as we go up the stack, we're starting to get more specific in terms of machine learning itself. I want you to be able to use the tools that you're familiar with. So let's say pandas. I don't want to ask you to learn some new tool for feature engineering. And similarly for machine learning libraries, I imagine you're going to want to try out a variety of different techniques, which means you're probably not going to want to be constrained early on to one particular machine learning framework. So when I look at this stack, I'm going to make a bold claim here, which is that you and your team, the farther down the stack you go, the less you care about the details of how these things are implemented. But you probably want to maintain the freedom higher up in the stack. And this is where our collaboration is going to be really cool, because we're engineers on the data science platform team, and we're all about infrastructure. And so we can actually reduce a lot of the toil by implementing some of these lower layers for you. Now the question is, where does this thing called METAFLOW fit into the picture? You can think of METAFLOW as a wrapper around these layers. It's an interface that the data scientists can use to do their work without necessarily having to interact with all of these different systems to bring them together. It does that for you. I think we're now ready to talk about how to use METAFLOW itself. So we'll start with the prototyping phase, and my question for you, Ashish, is what particular programming languages do you like to use?
Yeah, so the data scientists on my team use Python for most of their development.
Okay. Anybody else use Python? Okay, some hands. Anybody use R? Okay, a couple people. If you're using Python or R, METAFLOW will work for you. And we're going to show the examples in Python. However, if you're using R, you can do the same thing with R. I want to go through a little bit in terms of the prerequisite knowledge. First of all, you need to know what a function is. You can think of a function as this black box of compute that takes some data input and produces some output. That's all you need to know to build the fundamentals of workflow on top of METAFLOW. The only other thing that you really need is how to run things on the command line. And that's enough to get you started. So let's look at how you might structure your work. Many of you who have built machine learning pipelines are already familiar with the idea of creating a workflow that has a series of discrete steps. And we often refer to this structure as a directed acyclic graph, or DAG. And when we build one of these in MetaFlow, we often call it a flow. So if you hear me say DAG or flow, I'm basically referring to this structure. How would you create one of these structures using code? What you want to do is write basically vanilla Python code with a couple of modifications. What you're going to want to do first is create a class. And the class needs to implement something called a flow spec, which provides you all the MetaFlow magic that you need to make this work. You don't have to do anything else. Now, I talked about functions earlier, and the functions are literally going to be these nodes in this graph here. And you can tell MetaFlow that you're creating a node in the graph by adding a decorator called step. And then in order to draw the arrows between these nodes in the graph, you're going to call something next that's going to say, hey, after this start step, I'm going to do PCA and feature engineering next. And MetaFlow will use that to create your DAG at runtime. The cool part here is that you just run it like you would run any other Python script. You can use your own local development environment. You don't have to log into a cluster or configure anything. You just run it, and it works. I'm going to talk a little bit about some of the magic, though, behind MetaFlow, because this feature here is very important to some of the very cool stuff you can do with it. And fundamentally, what you can do here is you can reproduce work. You can go back to previous states of your work, and that is all thanks to this underlying thing called an artifact store. As a MetaFlow ML modeler, you don't have to worry about this at all, but it's helpful to understand. So what this artifact store is used for is persisting the state of your step after it completes. Let's see how this works. So we have a variable called x, and at the end of your start step, x has a value of 0. And MetaFlow will take that and pickle it, or serialize it for you. And when you start the next step, you can refer to the last value of x. So in this case, we have the PCA and the feature engineering steps, and they do different things with x. So this one, the PCA increments it to 2, and the feature engineering increments it to 3. So here's the super cool part. When you come back together and join these two steps, you can examine the previous states of x from all of these steps, and you can do operations on it. So in this case, we selected the max value of 3. So maybe you're starting to imagine that if we are training different models in parallel, we can actually go through the previous trained models and find the best fit model. But that's not all. There's actually a really cool feature that'll help you out in the prototyping phase. Let's say you have a model pipeline and it takes 45 minutes to run. The last thing you want to have happen is at minute 42, you get a failure. You don't want to have to debug, update your code, and then rerun and wait another 42 minutes to find out if you fixed the problem. MetaFlow lets you short circuit this, and let's see how this works. So let's say I run my flow, it plays the start step, completes. We're now running these two steps in parallel, but imagine that the PCA step succeeds while the feature engineering step does not succeed. Luckily, all you have to do at this point is go figure out what went wrong with your feature engineering step, and you can run a command called resume. And resume will say, please start at the feature engineering step. And what MetaFlow does at this point is it will start from there, and it will use the artifact store to pull up previous results of successfully run steps for you, and you can continue on your merry way and finish your workflow. Okay, now let's say that at some point you have been experimenting on your local machine, but you're only using a slice of the data because if you use more, your machine would just fall over. You still want to be prototyping, but you want to use the whole data set. So the question is, what do you do? With MetaFlow, you can easily scale your model through access to practically unlimited compute in the cloud. In our case, we're using Titus, but you can imagine the same thing might work for Kubernetes. What you can do is take the code that you've already written and add a decorator to it. So we have a Titus decorator that takes a couple of parameters. You can ask for CPUs, GPUs, or memory. So if you have a CPU-intensive job like PCA, METAFLOW will take that particular step and run it on Titus for you. And if you have a memory-intensive job like feature engineering, you can do the same thing. And the cool part is, you're still in your local development environment. You are still running this on the command line, and METAFLOW is taking care of all the work of how to get this out into the cloud and running and get the results back. Okay, now you might be wondering, how do we do something more fancy? How do we create more parallel tasks? What if we want to do a hyperparameter grid search? This is actually pretty straightforward. In this example, let's say we're training a forest, and we want to test with different numbers of trees in the forest. What you need to do here is create a data structure that has the various hyperparameter combinations that you need. Then what you can do is say, hey, METAFLOW, please run the train step for each item in this data structure, and METAFLOW will automatically create that train step for each value that you have in the data structure. So you can very quickly and easily start to distribute your work in parallel. So the next step that we're going to need to think about is, how do we get to production? Let's say we have a prototype. We're at the end of that sort of 6-week phase where we're happy with what we have, and we want to go to the next step. We want to run and train our model on a schedule. Luckily, METAFLOW already supports this DAG structure, which many enterprise-grade schedulers already support. What you can do is take the exact same code that you've written, no need to port, no need to rewrite, and have that scheduled on your production job scheduler. In our case, it's Meson. So you run a simple command, in this case, Meson create, and METAFLOW will take that DAG, map it onto the scheduler, and from there you can create a schedule that's going to work for your models. We also want to make sure that we can provide real-time insights in production to our models. So let's say, for example, we need to have a web service that you can send in features and retrieve a score. So you want to do some kind of live scoring. And looking at the logic, I want you to pay attention to just the code that's inside of this method called predict. You can use what's called the METAFLOW client API to retrieve results that were previously stored in METAFLOW runs in the artifact store. In this case, we're pulling up a previous METAFLOW run, and we are looking at a particular data artifact, which happens to be your model that was pickled. And METAFLOW will automatically deserialize that for you. So what you just need to do is pull that model in, score it, and return the results. Okay, but how do you turn that into a web service? Luckily, you don't have to write your own Flask application to do that. What you can do is create a class around that method and implement another magic class called web service spec. And you just tell METAFLOW, hey, this function here that does this scoring, this is an endpoint. What METAFLOW will do is it will provision that endpoint, it will deploy the model, and it will link to the previous runs of your flow. And so in this case, we get a new method called predict, and that can be called directly from a curl command or from whatever REST client you need. Using JSON, it'll return the results. So that'll alleviate you from some of this burden. Ashish, now that we've kind of gone over the basics of using METAFLOW, do you think this is something that your team will be able to use?
Yeah, Julie, this sounds amazing. It really just hides the accidental complexity associated with building machine learning pipelines and allows data scientists to remain in environments that are close to their environment in which they're comfortable and really increases their productivity. So this sounds really cool.
Okay.
Thank you.
Excellent.
Right. Cool.
See you later.
See ya. Bye. Oh. Okay.
A few months later.
A few months later. Hey, Julie, remember that METAFLOW thing you showed?
Yes, I do remember that.
Yeah,
METAFLOW
well, that
thing.
was really cool. Data scientists on my team are loving it. They're building models really fast. They're pushing them to production. Everyone's really happy. There's a lot of collaboration. It's amazing. But now I have a slightly enhanced or a different challenge for you. So the data scientist that built this model to predict the demand of content has since moved to a different team. And so now we have the situation where this model exists and it needs to be iterated upon. So recently we've noticed that the model performance has started to drift. We need some tools to audit the performance, inspect the model, and there are some ideas where a cool sister team is building these embeddings, and we'd like to incorporate these embeddings. So basically, we have the need to start building a V2 of the model. Fortunately, I have another data scientist on my team who started just recently, and this data scientist now needs to take on the V1 and build upon it with a V2. And this task, for many of you, sort of it falls under maintenance. And people who are in New York City, as most of you probably are very, very familiar with the pain of maintenance. Often you'll notice at the subway sign that the subway is stopped for upgrades or for maintenance. And what we don't want is, as we're developing the second version of the model, we have to sort of pull down the version 1, or we have to stop offering insights from version 1. So what we'd really like is to keep version 1 running in production, somehow clone it, and for this other data scientist to then start working on a V2 while V1 is still running in production, and then when the time is right, to push V2 to production. So Julie, is there anything that METAFLOW can offer to help with this maintenance phase that can take up to 6 weeks, 6 to 8 weeks for a data scientist?
Yes, absolutely. One thing I didn't talk about before was how you can use the METAFLOW client API to monitor your models, and you can use it using your familiar tools. So we're going to talk about using METAFLOW to inspect your model. You can pull up the client API in a typical notebook. So what you're doing here is you're importing the METAFLOW client API. You use that to instantiate your flow and then pull up the latest successful run of your flow. Just a side note, every time you run a flow in METAFLOW, it gets a run ID. And the run ID is just a number, and the number increments every time you run that flow. This latest successful run in the middle cell shows you really what the highest number run actually is. Once you've pulled up the run, you can start to inspect the data artifacts that were stored for you in the artifact store. In this case, we have a run that concludes a feature engineering matrix in this do feature engineering step. So not only can you retrieve artifacts from the end of your flow, but you can retrieve any intermediate state of the flow. In this case, we want to inspect the feature engineering matrix. METAFLOW pulls that down and deserialize it for you. And from there, you can use all the familiar tools at your disposal to deal with data frames. We can do things like plotting the feature engineering matrix. And one cool thing is you can actually iterate through all previous runs and look at how those features change over time. So that would be a good way to do things like drift detection. Now, the other thing you talked about was this idea of, well, you have somebody leaving the team, somebody else wants to pick up the work, you don't want to mess up production, you want to work on V2. Something I didn't talk about before was around how METAFLOW will organize your work. So let's see how that's going to work. Suppose you, Ashish, have a flow called MyFlow, and you run that flow. METAFLOW will create this run, and it will tag it implicitly with your username. So you don't know that's happening, it just happens by default. The idea is METAFLOW is trying to isolate work from individual users by default, so there's no fear of your work interfering with somebody else's. So let's say later you want to pull up this run using the METAFLOW client API. You grab the latest run and you get run ID number 99 over here. Okay, what if I'm running a flow called MyFlow? It's the same name. When METAFLOW runs that, it's going to give my username here. And when I want to pull up my latest flow, oops, went too far. When I want to pull up my latest flow, I'm going to get a run ID of 100, right? Because I ran it again, so it's not 99, it's 100. Now, Ashish, if you were to use the client API again, what do you think you're going to get? You're going to get 99 or 100? You're actually going to get 99, because that was your latest run. You're not going to see my work. So how are you going to see my work? What you can actually do is specify a particular namespace. So instead of saying, just get the flow, you can say namespace equals my username. Then all of a sudden you're seeing my latest run. That's cool and all, but I might be tinkering around pretty rapidly, and so you might actually not even know what does run number 100 mean. So it would be great if you and I could have a contract or an agreement to sort of name a certain body of work that we can all work with. And that's where this idea of tagging comes in. So if we want to work together on version 2, I can actually run my flow using this tag v2. I'm going to run it. I'm going to get version number 101. And Ashish, if you want to look at my results, you simply use the namespace v2, and you're going to get the same exact work. It's also worth mentioning that when you run flows in production, through the job scheduler, METAFLOW automatically tags this with a production-level namespace that is separate from all the user namespaces, which means we're operating in isolation, and we don't have to worry at all about messing up with production. So let's say time passes, and the project V2 is delivered. So Ashish, let's do a retrospective on this project.
Yeah, Julie, I just want to say thank you. METAFLOW has been a big boon to productivity for data scientists on my team. It's fostered collaboration, it's made them faster, it's hidden a lot of the accidental complexity that goes into bringing impact through machine learning by sort of deploying and productionalizing machine learning pipelines. And it's got this human-centric perspective that really enables scientists to work together and deliver impact to the company. So thank you so much for this innovation. It's been pretty awesome.
Very cool. I want to just spend a minute addressing, the question of how METAFLOW works across projects, because we didn't build it just for content machine learning. We built it to work across ML projects at Netflix. So one thing that we look at for how do we know whether we're successful is, does METAFLOW get adoption? There's nobody at Netflix that sort of declares what technology people are allowed to use. Data scientists have a lot of freedom to choose what's going to work for them. And so METAFLOW has been around within Netflix for about 2 years, and we've had a pretty nice adoption curve across many projects. In fact, we have over 600 projects running on METAFLOW today. And then the other thing we wanted to look at is, are we actually accelerating the work of data scientists? Can we get you to production faster? And not all projects go to production, but for the ones that do, we find that data scientists are able to get their models to production for the first time within a week most of the time. So that's a very quick iteration to find out, hey, is this thing going to scale? Is this thing going to run in production? Just to wrap up, we've given a few talks over the last year or so about METAFLOW, and one of the first questions that we get is, are you going to open source METAFLOW? Well, it turns out that this quarter we're exploring METAFLOW's applicability outside of Netflix. So if you are interested in talking about using METAFLOW at your company, please come talk to me. We also have a METAFLOW developer in the audience somewhere, Ravi over here. Do you mind standing up? So Ravi here is a developer of METAFLOW, so if you want to chat afterwards, please talk to Ravi, talk to me. I'll be around here, Strata tomorrow. Ashish is here today. So thank you very much.
All right, thank you. Any questions?
1 minute.
There you go.
How do you clean unused models and stuff, unused projects, and like if something like old or like, do you have like cleaner or something, or you have to manually do that?
Okay, so the question is, how do we clean old models? Data scientists, at least in terms of our experience using AWS as our cloud platform, we find that the cost of a data scientist tends to be much higher than the cost of the resources that they're using. And so while we do have some kind of garbage collection, we actually store your METAFLOW artifacts forever so that you don't have to worry about this thing going away. And that's actually way cheaper than the time you might be spending to recover an old project.
600 projects on, how many people would that be spread over? About 200?
So actually, one data scientist can do quite a few projects. I'm trying to recall the specific how many active users we have, but it's actually under 100 users.
So if I have different versions of models, and can I revert back, and how does this like flow, like store versions of models?
Yeah, and that actually is all taken care of for you in the MetaFlow artifact store. So I mentioned the run IDs increment over time, and you can actually go back to any specific run ID, you can tag it, and retrieve that and use that as your starting point for new work. Happy to chat more afterwards if you have more questions.
Thank you.
Thank you.